Hi, and welcome to my channel. From H.G. Wells' The Time Machine to the iconic DeLorean in Back to the Future, time travel has captivated our imaginations for centuries. The idea of journeying through time, witnessing historical events, or even glimpsing the future is a tantalizing prospect.
But is time travel merely a product of our wildest fantasies? Or could it be grounded in scientific reality? Modern physics, particularly Einstein's theory of relativity, suggests that time is not as rigid and unchanging as we once believed.
It proposes that time is intertwined with space, forming a flexible fabric that can be warped and stretched by gravity and motion.
Could there be shortcuts through this cosmic fabric, allowing us to leap across vast temporal distances?
Before Albert Einstein, time was considered an absolute, ticking away at the same rate for everyone, everywhere. However, Einstein's groundbreaking theories of special and general relativity revolutionized our understanding of time, space, and gravity.
In his special theory of relativity, published in 1905, Einstein proposed that time is not absolute, but rather relative to the observer's frame of reference. This means that time can pass at different rates for observers who are moving at different speeds relative to one another.
Einstein's general theory of relativity, published in 1915, expanded on this concept, demonstrating that gravity itself can warp the fabric of space-time. Massive objects like stars and black holes create distortions in space-time, causing time to slow down in their vicinity.
These groundbreaking ideas challenged our fundamental understanding of the universe and opened up the possibility that manipulating time might not be as implausible as once thought.
One of the most intriguing consequences of Einstein's theory of special relativity is time dilation. This phenomenon describes how time slows down for an object in motion relative to a stationary observer. The faster the object moves, the slower time passes for it.
Imagine two identical clocks, one at rest and the other traveling at a significant fraction of the speed of light. According to special relativity, the clock in motion would tick slower than the stationary clock.
This difference in timekeeping is not due to any mechanical malfunction, but rather a fundamental property of space-time itself. While the effects of time dilation are negligible at everyday speeds, they become increasingly pronounced as an object approaches the speed of light.
At speeds close to the speed of light, time dilation becomes so significant that it could theoretically allow for journeys across vast cosmic distances within a human lifetime.
While time dilation suggests that time travel might be possible, there's a significant catch: the speed of light. According to Einstein's theories, nothing can travel faster than the speed of light, which acts as a cosmic speed limit. This presents a major hurdle for aspiring time travelers.
Even if we could build spacecraft capable of approaching the speed of light, reaching a distant star system and returning to Earth within a human lifetime would still be an incredibly lengthy journey.
However, physicists have proposed hypothetical particles called tachyons, which are theorized to always travel faster than light. If such particles exist and could be harnessed, they might offer a way to circumvent the speed of light barrier.
The existence of tachyons remains purely speculative, and their existence would raise a whole new set of paradoxes and challenges to our understanding of physics.
Section 5. Wormholes, shortcuts through space and time. Another intriguing concept that could potentially allow for time travel is the wormhole. Wormholes are theoretical tunnels that connect two distant points in space-time, essentially creating shortcuts through the fabric of the universe.
Imagine folding a piece of paper in half and poking a hole through both layers. The hole represents a wormhole, allowing you to travel between the 2 points on the paper much faster than traveling across the surface.
While wormholes are consistent with Einstein's equations of general relativity, their existence remains purely theoretical. Physicists have yet to observe a wormhole directly, and creating one would require manipulating immense amounts of energy, potentially more than the total energy output of the sun.
Section 6. The grandfather paradox untangling time's threads. The possibility of time travel raises a host of logical paradoxes, most notably the grandfather paradox. This thought experiment highlights the potential contradictions and inconsistencies that could arise from altering the past.
Imagine a scenario where a time traveler journeys back in time and accidentally kills their own grandfather before their parent was even conceived. This action would seemingly make it impossible for the time traveler to have ever existed in the first place.
The grandfather paradox raises fundamental questions about causality, the relationship between cause and effect. If the past can be changed, it throws the very notion of cause and effect into disarray, potentially unraveling the fabric of reality as we know it.
Section 7. Closed time-like curves, a mind-bending possibility. While the grandfather paradox presents a significant challenge to the idea of changing the past, some physicists have proposed that time travel might be possible without running afoul of causality. One such concept is the existence of closed time-like curves, CTCs.
CTCs are theoretical pathways through space-time that loop back on themselves, potentially allowing for travel through time. However, unlike traditional notions of time travel, CTCs would not allow for changing the past. Instead, any actions taken by a time traveler within a CTC would be predetermined, ensuring consistency with the already established timeline.
In essence, CTCs suggest that the past, present, and future are all fixed and immutable, with time travelers merely playing predetermined roles within the grand tapestry of space-time.
Section 8. Time travel experiments. A glimpse into the future. While human time travel remains science fiction, physicists have conducted experiments hinting at the nature of time.
One experiment sent muons, heavier than electrons, through a particle accelerator. Their high speeds caused their internal clocks to tick slower due to time dilation.
The experiment confirmed special relativity predictions. High-speed muons decayed slower, proving time dilation is real.
These experiments suggest time is complex, and manipulating it on a subatomic level might be possible.
Section 9. The ethics and implications of time travel. Beyond the scientific hurdles, time travel also raises a plethora of ethical and philosophical questions.
If time travel were to become a reality, it would have profound implications for our understanding of free will, morality, and the very fabric of history. Imagine the potential for abuse if someone could alter the past for personal gain or rewrite history to suit their own agenda.
The ability to travel through time would require strict ethical guidelines and regulations to prevent unintended consequences and paradoxes.
Furthermore, the very act of observing the past could inadvertently alter it. The observer effect, a well-established principle in quantum mechanics, suggests that the act of observation can influence the behavior of particles at the subatomic level.
If similar principles apply to macroscopic events, then even passive observation of the past could have unforeseen and potentially catastrophic consequences. Section 10. The allure of the unknown. Our fascination with time travel. Despite the scientific, ethical, and philosophical complexities, the concept of time travel continues to fascinate us.
It represents the ultimate escape, allowing us to break free from the constraints of time and explore the infinite possibilities of the past and future. Time travel stories, whether in literature, film, or television, offer a form of escapism, allowing us to explore alternate timelines, witness historical events firsthand, or even glimpse into the distant future.
These stories often serve as cautionary tales, warning us about the potential consequences of tampering with the past or attempting to control the future.
Yet, beyond their entertainment value, time travel stories also reflect our deepest hopes and fears, our desire to understand our place in the grand scheme of time, and our yearning to connect with the past and future.
Section 11. Time travel. A dream for now, but what about tomorrow? While the possibility of time travel might seem like pure science fiction today, it's essential to remember that our understanding of the universe is constantly evolving.
What might seem impossible today could become reality tomorrow, thanks to groundbreaking scientific discoveries and technological advancements. The pursuit of understanding time travel, even if it ultimately proves impossible, pushes the boundaries of our knowledge and inspires us to think beyond the limits of our current understanding.
It encourages us to question our assumptions about the nature of reality and to explore the vast, uncharted territories of the cosmos.
Whether time travel remains a dream or becomes a reality, the exploration of this mind-boggling concept will continue to captivate our imaginations, fueling our curiosity about the universe and our place within it. Who knows what wonders await us on the other side of the cosmic clock? Only time will tell. If you like this video, like this, and write your comments and subscribe my channel. Goodbye until the next video.